Welcome to Unit 2 of the Go programming tutorial from tutorialcoding.com. Variables are the backbone of every program. In this unit, I'll explain their parts, how they are declared and initialized, explain what scope they live in, introduce the fundamental types that you will need in most programs, touch on the blank identifier, show a library function that retrieves the type of a variable, and finish with the sample application and summary. Each variable has three parts: an identifier, a type, and a value. The identifier is the name that you use to address variables. A valid identifier consists of characters, numbers, and underscores, but cannot start with a number. X, x1, and underscore x are valid names, while 1x is not valid because it starts with a number. The type of a variable tells what kind of values it can hold. Go is statically typed, meaning that once you declare the variable, its type won't change until the variable dies. A variable has a value that matches its type. If not initialized, it will have the default value. The value of a variable can be changed indefinitely as long as the new value matches the variable's type. If you want to convert the value of a variable to another type, you will have to assign the result to a new variable that has the desired target type. The most expressive form to declare a variable is to use the var keyword followed by the variable identifier and its type. This will create a new variable and initialize it to the type's default value. After the variable has been declared, it can be used in computations and new values can be assigned. To save space, you can declare multiple variables of the same type at once. To do so, use the var keyword, then a comma-separated list of identifiers for the variables, and finally their type. Just in case you are wondering, there are 6 slides about declaring variables. Go gives you some choice in this regard. Most of them are useful in various situations. Here you can see a variable declaration block. This purely serves aesthetic purposes and saves you some typing. It can make your code a bit more readable, though it adds 2 extra lines. While you are declaring variables, you also have the opportunity to initialize their value. To do this, append an equals sign after the type and add the values as shown on the slide. Although Go is statically typed, you don't have to be explicit about the type of each variable when declaring them. When you initialize a variable during declaration, and only then, you can drop the type. In this situation, Go will determine the type of the value that you use to initialize the variable and use that for the declaration. You can even drop the var keyword. To do this, you will need to use the :equals operator that allows you to shorten variable declarations. At least one, but not all variables on the left side of this operator must be new. It works the same way as declaring a variable with the var keyword, initializing it and omitting the type. From a code readability standpoint, you should use this for short-lived variables that are used in close proximity. I recommend using one of the more explicit declaration forms for variables with a wider scope. A variable comes to life once it's declared and lives until the scope it resides in ends. A scope is generally defined by 2 matching brackets. For example, a function body is a scope. An exception is the package scope, which resides outside functions and stays around during the entire runtime of the program. You can declare variables with a name that has been used in a scope that is above the current one. When using the variable identifier, it will address the innermost one. The single underscore variable is special in Go. It's called the blank identifier and must not be initialized. Any value assigned to it will be discarded. It's basically a trash can for values. The reason it exists is that functions in Go can return multiple values, and sometimes you are not interested in all of them. In that case, you can selectively discard them. Here you can see a list of some fundamental data types that you'll often be using. The bool type carries a truth value. The int type stores integer numerical values. Depending on the architecture, its size is either 32 or 64-bit. The variants with the numerical suffix specify the size exactly. The variants with the U prefix only take positive values, which can be roughly twice as large as the sign counterparts. The float 32 and float 64 types take fractional numerical values. The string type holds text strings. And the byte type is an alias for uint8. It's used to represent binary data. The reflect package from the standard library provides a function that returns the type of a variable. It's rarely used in practical programs, but it's nice for demonstrations. If you want to build control flow based on the type of a variable, you will use type assertions, which I'll introduce in a later unit. The example here shows an executable program. It declares some variables with the different declaration methods introduced earlier. First come the 4 package variables. X is simply declared to be an integer type and is initialized to the default value of 0. Y is declared an integer type and initialized to 10. Z is implicitly declared through initialization as the sum of x plus y, which both have the integer type. As a result, Z will also have the integer type. Q is simply declared as a byte type and initialized to the default value of 0. The main function starts with implicitly declaring and initializing the a and b variables using the := operator. Again, the type is derived from the values that are used for initialization. So a will be a floating point number and b a truth value. C is then implicitly declared and initialized to a string type with the value spaghetti. The rest of the main function prints the values and types of all the variables. The column on the right side of the slide shows the output of the print function. To summarize, Go variables are statically typed. Once declared, they will insist on their type until they pass away. Go has many ways to declare variables. To improve readability, package variables should be declared explicitly. Variables that are only used for a short time can be initialized implicitly, saving a lot of typing and making the program more concise, which also improves readability. Scopes in Go are straightforward. You just need to look for the next matching closing bracket to find the boundary where the variables declared in the scope are terminated. The blank identifier is a valuable syntax asset that you will frequently use to discard unneeded values that are returned by functions. The reflect package is nice to print the types of variables. This concludes this unit. During this presentation, I mentioned a few things that I'll elaborate in later units, like functions and packages, so don't worry about them yet. See you next time. Thanks for watching. As always, you can find the unit sources and notes on the tutorialcoding.com website that you can reach by clicking on the box with the orange annotation. If you found this video insightful and enjoyable, please like it and leave a comment. Subscribe to my YouTube channel or follow my Google+ or Twitter feed. Goodbye.